let's suppose that they said solve sine of x tangent of x minus sine of x equals 0 for x, for 0 less than or equal to x less than pi, 2 pi, sorry. Okay, so let's suppose we have that equation right there. And we want to solve that. And notice that it only wants solutions from 0 to 2 pi. So to solve this, what is the dilemma here? Is it only one trig function? No, and that is the problem. You never want to solve equations with more than one trig function unless you can split those things into two separate equations. And there is a trick that we learned in college algebra that allows us to break this equation apart. What's common? Well, x is common, but actually there is no x expression in this equation, because remember, x is part of function sine of x. So this is one piece, this is one piece, this is one piece. What is the piece that's common to both terms? Let's go ahead and factor it then. And sine of x is common. So what I'm going to do is figure out sine of x times what would give me this expression. Tangent of x times sine of x would be this piece. And then 1 times, or -1 times sine of x would give you this piece. So then sine of x times tangent of x minus 1 would give you this piece. And if it helps to understand what really happened here, think of sine of x as like a, and tangent of x is like b. Well, sine of x is a. This is really the equation you're solving. And if you were to solve this equation, factor out a, you'd have b minus 1 equals 0. And then what's the trick that we use to solve something when we have it in factored form equal to 0? So I have this times this equals 0. What does that mean about one of those pieces? One of them has to be equal to 0. So this is multiplication here. So either a is equal to 0 or b minus 1 is equal to 0. And we can do the same thing over here. Either sine of x, this piece, is equal to 0, or tangent of x minus 1 is equal to 0. One or the other, or both. And then what I can do is go to my unit circle and look at the areas. And if you don't have a unit circle handy, either from the front cover of your book or from the study guide that I put on your class website, or something you printed offline, you're definitely going to want to have that because it'll save you so much time. And so if I look at the places between 0 and 2 pi, so that's just on the unit circle, where sine of x is equal to 0, what is one of the places where x would cause sine of x to be equal to 0? So 180 is one place, because if you rotate 180 degrees, sine depends on y. On the unit circle, the y value is sine, and the x value. Now remember, just like the discussion we had last week, when I am working in this equation, this x right here is an angle. Okay, these are all angles because they are the inputs of trig functions. They are not the same as the x value over here. Okay, so this x value over here is something completely different. And that's even though you're going to see this all the time with people using x's as inputs, you have to learn that that x is not related to the coordinate plane. It is the input of the function. Okay, So when this is tied together like this, you just have to think of that as like theta. And if it helps you avoid mistakes, rewrite it as sine of theta tangent of theta minus sine of theta equals 0, and then solve it. Just make sure your final answer is in terms of x. And is there any other places? 360. Now, is 360 less than 2 pi? No, but what angle is the same as 360? 0. Yeah, so it would be 180 or 0, and we'll talk about why this is not correct in a minute. So then tangent of x minus 1 equals 0. We can solve that by adding 1 to both sides. Okay, and now where is tangent equal to 1? But I'll remind you that tangent is really sine divided by cosine. When I'm finding where tangent of x is equal to 1, that means the sine and the cosine have to be the same, because tangent is y over x, or sine over cosine using the reciprocal identity. I see that x and y are equal right here, so 45 degrees. And I also see that they're equal right here, so 225. So then there's 2 places where this is true and 2 places where this is true. It wouldn't work at 135 because the signs are different, so you'd get a -1. But here's the rub. I want to go to the original problem, and what units were the problem written in? Radians. So since this is written in radians, your answer should be in the same units. So x, and then I'm just going to list them in order. I don't need to split them up like this. I'm just going to list all of the possibilities in order. 0 degrees is the same as 0 radians. 45 degrees is pi over 4 radians. 180 is pi radians. And 225 is 5 pi over 4 radians. And then this would be the correct solution. And then you could check your work by plugging these numbers back in, and you'll find out that it works. Many problems require using an identity to solve for the answer. And a perfect example of that would be something of the form that looks like this. So if I said solve 2 sine squared x cosine of x minus sine of x equals, now we'll keep it 0 for now, just tomorrow we'll handle the harder ones. Okay, so what do you notice is similar about this problem? It's equal to 0. Okay, so that part is the same. There is a strategy we used last time that we can also use this time. If we factor this one, what's common? Sine of x. Okay, and so if I take it out, there will only be one of them left here. And then here we'd have -1. Now it's factored, and I can do the same trick that I did before. Sine of x can equal 0, or 2 sine of x cosine of x -1 is equal to 0. The problem is this piece, because it's not one trig function. It looks a lot like something on your study guide and on your identity sheet. And what is this piece right here equal to? That is right. This is a double angle identity. It's the sine of 2x. Right. We already solved this one last time. Last time sine of x happened at 0 and pi, if I remember correctly. Okay, or 0 and 180 degrees. There's no units here, so you could use either units, and it would be fine. This one we solve by moving the 1 to the other side. This problem, where is sine of x equal to 1? 90, and that's it, right? Exactly. Yeah, down here is -1. So only up here is sine equal to 1. And so I know that 2x, the angle, has to equal 90 degrees. Or since I did radians over here, I should be consistent. So pi over 2. And then to find out what x is, so notice I just treated this as like an angle and said, what angle causes sine to be equal to 1? Well, the angle is pi over 2. And I could do a substitution if I wanted to. If it made it easier to understand, I could rewrite this problem as sine of u equals 1 by letting u equal to x. And then when I've solved this, resubstitute 2x back in for u. But problem this short is probably easier just to say the angle is pi over 2. And then divide both sides by 2. And so x would be pi over 4. And so now I have my solutions. I'll write them in order. And why is that not the answer? They didn't give us a range this time, which means there's an infinite number of answers. And if I look carefully, when I go from 0, so watch what happens here. If I go from 0 to pi, couldn't I just rotate another pi units around and get back to 0? So the easiest way to write this particular solution is to say x is, there's going to be 2 different parts to the solution. It looks like it's just multiples of pi. I can just rotate around, half a rotation each time. So it'd be some multiple of pi. And k would have to be an integer, which those of you who have been here before know that this means k is restricted to integers, not fractions, not decimals. So that would be one of the possibilities, rotating pi degrees around each time. When I plug in k equals 0, I get 0. When I plug in k equals 1, I get pi. When I plug in k equals 2, I get 2 pi, so on and so forth. Pi over 4, but this time pi over 4 is all by itself. It's kind of in its own little place, and really the only way to get back there is to rotate all the way around. So if you rotated all the way around, you'd get back to pi over 4, and a full rotation would mean adding 2 pi to that answer some number of times. Okay, so this is more like what you guys remember seeing probably from earlier. This right here is what it looks like when you have a singleton in here and you just have to rotate all the way back around to get all possibilities. This is what it looks like when you have a pattern where you can just rotate repeatedly a certain increment. You figure out what the increment is, and then you multiply by a number. In this case, 180 degrees or pi. And then this right here would be the whole solution. Evaluate sine of u over 2. Is that kind of what you're talking about? If tangent of u equals, let's say, square root of 3. Okay, and u is an element of quadrant 3. To do this problem, the first thing is to start with the identity. So sine of u over 2 is equal to plus or minus the square root, and this is really important, that this is written everything inside the square root. And one of the big problems people have on the quiz is they don't rationalize, and so their answer will not match one of the questions. And then for sine, it's 1 minus cosine of u. Is that correct? In order to solve this problem, I need to go and figure out what cosine is. I know that tangent of u, and it says u's in quadrant 3. So u is here. Tangent is y over x. So this means that my y value would be square root of 3 and my x value would be 1, because this is like square root of 3 over 1. And then I can use this information to solve for r. Using the Pythagorean theorem, x squared plus y squared is always equal to r squared, because here's r, here's x, here's y. So that would be 1 squared plus root 3 squared equals r squared. And so that's 1 plus 3 equals r squared. So 4 equals r squared. So r equals, and here is where people get stuck. Remember that r cannot be negative. Absolutely cannot be. And so if you look up here, I made a fatal mistake. And this is the mistake most students make. What did I say y and x were? I said they were positive. Are they in quadrant 3? No. So my big mistake up here, and this is the mistake that people make a lot, is I'm not keeping track of the fact that I am in quadrant 3 over here, which means that my signs are negative. That meant all of these should be negative. That's not going to change r though, but it does have an impact later on in the problem. Oh, whoops, that'll be positive when I square it. That will be positive when I square it. Okay, and I'll still get a positive 4, but r has to be positive. Okay, so r will be positive. Now that I've done this, I actually know exactly what sine and cosine are. I know cosine of u, this is my angle u. There's angle u. So cosine of u is x over r. So x over r. So there's my cosine of u. And here's where most people have made their mistakes, is not having the correct sign for cosine. And so it alters their answer in here. And then the second place is not choosing the correct one here. So it's plus or minus square root of 1 minus 1/2, because that's cosine of u, over 2. But if you looked at the quiz questions, the 2 is never included in the root in the final answer because that's not rationalized. And so what I have to do is rationalize it. And the easiest way to do that is to figure out what to multiply by that's going to get rid of all the fractions up here. I'm going to multiply by 2, and it happens to work out that 2 times 2 is 4, which means inside of my square root, oops, plus or minus, I'm going to have a nice number in the bottom. And if I distribute this out, 2 minus 1, and so when I'm all done, I'll have, in this case, just a 1 over a 4, but it's really important that if this top part or this bottom part simplifies, you need to not leave it inside the root like that. So for the quiz, you would have, since it wanted a square root in the top, I would have left this as just a 1 inside the square root, but it only had a 2 in the denominator. So I needed to take the square root of 4 to get 2. So if I was answering this on the quiz, my answer would have been 1. If I had had other stuff in here, like roots or something, then I just would have written down whatever was inside of here, inside the root. That would have been my answer for the problem where it said, write the expression inside the square root. But I need to know whether the answer is positive or negative, and that's the last place where people make mistakes, because they forget that now I'm not looking at angle u anymore. For the final answer, I'm looking at u over 2. And if u is in quadrant 3, that means u is between 180 and 270. So then u over 2, I divide everything by 2. U is between 9, or u over 2 would be between 90 and 135, which that is in quadrant 2. And in quadrant 2, sign would be positive. And so for the final answer that I would get out of this, this would be positive. The expression inside the root would just be a 1. Or if I was just giving an answer, I could actually simplify the whole problem and I'd just get positive. Square root of 1 is just 1. So I just get positive 1/2. I chose one that worked out nicely numerically so that we didn't get confused by all the numbers. Okay, I just want to make sure it's okay. So it said use the half angle identity to evaluate. So evaluate sine of 5 pi over 12. To do this problem, we want the sine of u over 2 because we can't directly evaluate that. That means that unlike the last problem, this one has a slightly different step, and that is that since I didn't give you information about tangent or cosine, I'm going to have to find an angle myself. But I know that u divided by 2 has to match this. So if I write an equation, u over 2 equals 5 pi over 12, I can multiply both sides by 2, and I get u is 5 pi over 6. So then when I go to calculate my identity using the half angle identity, sine is 1 minus cosine of u. Cosine, I need to know cosine. And in this case, my u is 5 pi over 6. So sine of 5 pi over 12, which is my u over 2, would be the square root of 1 minus the cosine of 5 pi over 6. And then that right there, cosine of 5 pi over 6, if I go to the unit circle, 5 pi over 6, cosine is x. So it'll be 1 minus a negative root 3 over 2. And I'm going to do the same trick that I did last time, which is to multiply top and bottom by 2, because then this bottom piece will simplify, and so will the top. This is really a plus, and then I have to distribute. So I'll have 2. The 2's here will cancel, so I'll just have root 3. In the bottom, I'll have a 4. And then I can simplify this because I can break it apart as the top, and I can break it apart as the bottom. And so then I'd have plus or minus the square root of 2 plus root 3 over 2. So I'm going to have to go to 5 pi over 12 now. I know that 5 pi over 6 is 150 degrees. So what's a half of 150? 75. So I'm going to be here, which is in which quadrant? Quadrant 1. So this angle is in quadrant 1, and therefore sine would be positive. So sine of x would be greater than 0 in quadrant 1. And so I would have a positive answer, not a negative answer. So when I'm all done, the sine of u over 2, the sine of 5 pi over 12, that was my original problem, would be positive square root of 2 plus root 3 over 2. So when we are evaluating sine of 5 pi over 12, that is this angle right here, which is not nice. But I noticed that if I double this angle, I get to here, which is a nice angle. So I'm going to call this angle here, this full angle out to here, I'm going to call this U, which means then I need to calculate half of U to get the angle I actually want. So by using the half angle identity, I only have to know angle U. I don't need to know this angle at all.